Hello, eighth graders. This would be the new topic that I'll be teaching you guys for today. The test that you guys have taken 2 weeks ago, it's already been 2 weeks on Friday. The topics that we needed to work on were similar triangles, equations of circles, and etc. And there was really no clear um, set of guidelines for me to assign you those work. Taking a look at the test, and I do believe that there were some questions that might have been a little bit challenging, but for the most part, I felt that you guys should have been able to do okay. But since the scores were very, very low, a lot lower than what we have actually hoped for, it seems that we had a little bit of a buffer week for the geometry topics. But starting from today, what I'm going to start working you guys on is we're going to elaborate on the trigonometric the functions and how to find out the a little bit more elaborate trigonometric you know angles, and we're not going to be restricted to acute angles. We're going to be actually doing a little bit more. So it kind of builds into algebra 2, even pre-calculus. However, because this is mainly dealing with trigonometry, SOHCAHTOA stuff, I believe that you guys can all handle it. Today we're just going to be talking about reference angles and how to solve for them. And there's a homework that goes along with this that I would like you to work on, okay? So first of all, you guys should all have the slides with you as well in this file. What I would like you to do is I would like you to take the time or pause the video right now and really work on this, say, the table, okay? So we've been doing this countless times, and I know for a fact how you guys can solve for sine of 30, cosine of 45, and those kind of things. So please pause the video now and draw this table on your notebook and fill out the table for me, please. Okay, so since you're playing it back, I'm assuming that you guys all have this value. It should be 1/2. This should be root 2 over 2, and this should be root 3 over 2. Root 3 over 2, root 2 over 2, and that should be 1/2. This should be 1. And tangent of 30 degrees, that's root 3 over 3, and this is just root 3 here. Okay, so you guys have those values there. Now, on the second slide, what I've done for you here is I have given you a new set of trigonometric trigonometric values that you're going to have to solve for. Last maybe a couple months ago, we have done something like this in the past, where we filled up all the values of the unit circle. And so if you have this chart with you, that's great, because all of the values that we have found out for sine, cosine should be in your table. So for example, cosine of 30, remember your unit circle always follows cosine of the angle, sine of the angle. So this first value here is cosine of 30, and this right here is sine of 30. And what do you know? If you take a look at this value, sine of 30, cosine of 30 matches exactly these two right there respectively. Now, the reason why I'm giving you this new set of these what we call obtuse angles, and more so that you'll see in the third and fourth quadrant with 210 degrees, is because now no longer will you be restricted in the interval of 0 to 90 degrees. We're not going to be talking about acute angles anymore. We're going to be talking about finding trigonometric values when it's going to be these values specifically. Now, then how do we, we can't really imagine, right? So for example, like sine of 30, we can visualize using a right triangle, and we can visualize opposite, hypotenuse, and adjacent, and we can all do that. But no, we cannot do this visual part for these guys right here. What you really have to understand is now you're going to have to be looking at what we call a Cartesian rectangular coordinates. Okay, that's just fancy word for saying x and y's. You're going to be having to take a look at the x and y in a coordinate plane and see where the x's and y's are listed, and then those will be the answer that you find out how to get your cosine value, your sine value, and your tangent value. Okay, so from this part, what I would like you to do is I would like you to fill up this chart as well. So from before, we have all of this, I'm pretty sure. So you guys don't have to rewrite this constantly over and over again. You can keep on adding this stuff, adding and adding more and more columns next to it. So you guys don't have to really worry about that. And And so if I have these values, now what I want you to do is I want you to fill up the values for here. Pause the video now, and if you want to take a look at the unit circle, that's fine. But what I would like you to do is fill up the table using the unit circle chart that's on this slide, and then just find out the sine, cosine, tangent value of those for me, please. And to find out the tangent value, if you guys don't remember, tangent is always going to be sine over cosine. So whatever that you found out for sine, you're going to have to divide it by cosine to find out the value of the last value. So for example, if I were going to find out tangent of 30, obviously you guys understand drawing the triangle out and doing those things, but tangent of 30 is same as sine of 30 over cosine of 30. And so if you do 1/2 over root 3 over 2, the 2's will cancel out and you will get 1 over root 3. Rationalize it and you get root 3 over 3. So that's where this root 3 over 3 came from. So just remember that identity and please plug in the values for me. Pause the video and play it again once you're ready. Okay, so now assuming that you guys are ready, let's take a look at the sine of 120, 135, and 150. What you should have noticed was that all of these values will give you the exact same thing for this guy. But for cosine, you're going to get a negative values for these guys, right? And then what you're going to get for tangent, okay, well, first of all, let's take a look at 120 degrees. Your x value is negative 1 over 2. So, actually, no, wait a minute. Yeah, so, or you guys can use a calculator for this as well. If you guys do sine of 120 degrees, I believe what you guys are going to get is you guys are going to get okay, wait a minute. So that was a mistake. If we were in school, there would have definitely been a mistake right there. Okay, but let's fix this real quick. Okay, so when I plug in sine of 120 into the calculator, I should have actually showed it to you this way. I get a 0.866. That's the same value that what you were going to get if you actually did root 3 over 2. Makes sense because we're going to be talking about reference angles, but let me get to that after I fill up all these values. So sine of 120 actually gives you root 3 over 2. The 135 should give you root 2 over 2 for these guys. But for cosine of 135, you guys should get a negative value. So if you guys actually go to your calculator and type in cosine of 135 degrees, you guys are going to get negative 0.707, which is the same as square root of 2 over 2, but you're going to have to put a negative sign in front of it. Now, 150 degrees would be 1/2, and make sure that you know that these two would be kind of crisscrossed. So this would be 1/2 here, and this would be root 3 over 2. But you guys have to put the important negative sign in front of all of these guys. Why? Because cosine in what we call the second quadrant, and this is your first quadrant, the second quadrant, only sign you will see that it's positive. Okay? Your tangent values are all going to be negative because, like I told you before, tangent is nothing more, okay, than sine over cosine. So if you apply it to here, here, and here, that means that if you take the sine value and divide it by the cosine value, you're going to get the answer, but you're always going to end up with a negative because it's positive divided by a negative sign. So this here, if you type in tangent of 120, I believe you get square root of 3, exactly, yes, so negative square root of 3, of course, and this would be negative 1, and this would be negative root 3 over 3. Okay, and those values would be coinciding with this on the unit circle because the very first value here will be your cosine, and this value will be your sine. So the sine of 120 is positive root 3 over 2, but the x value, because we're talking about the negative x coordinates here, you're going to get a negative value for your cosines. Hence, your tangent is also going to be negative. Okay. Now, if you fill up the table part right there by using this trig identity or the unit circle identity, you'll find out that you'll see a lot of these root 3 over 2, 1/2, root 2 over 2 as a pattern. Every 45 degrees is pretty much consistent. Root 2 over 2, root 2 over 2, 1, root 2 over 2, root 2 over 2, and 1. And the question is it positive or negative? That's basically what it comes down to. In here, if you guys take a look, these two values here and here, notice that sine and cosine, they're both negative, okay, because both x and y's, they're both negative coordinates. So I'm going to put a negative sign here and here. And the tangent ends up being positive because negative divided by negative gives me a positive 1. Now, in your fourth quadrant here, you're going to see how sine is going to be negative because, take a look at how your y value is negative, but your x value, you're talking about a positive x coordinate. So your cosine will be positive, so negative divided by positive gives me negative. So that's why you're going to get a negative 1 for that one. Now, what about the rest? Well, sine of 210 degrees. You guys can type that into your calculator to verify your answers there, but what I see is that it's negative 1/2, just like you will see on your y value for 210. Well, that's because we're talking about the y values. Now, the y values would all be in the negative zone, okay? These are all the negative x values. So let's copy and paste that all, like everything. So this right here would be square root of 3 over 2. But notice how this would be negative as well. Now the cosine, they will also be negative because both, like I said, x's and y's, they're all negative values. Okay? So now what about the tangents then? Well, the tangent is negative divided by negative, negative divided by negative. So what actually turns out to be is that all of these values turn out to be positive. So, if you take sine divided by cosine, 1 over 2 divided by root 3 over 2, you guys can do keep, change, flip, and so you'll get this, and so you will get 1 over root 3, rationalize it, you get root 3 over 3. Rationalizing means, guys, you're multiplying the top and bottom by root 3 over root 3. This becomes root 3 over root 9, becomes root 3 over 3. That becomes whatever that is. Here, you do it the same way. Like, you would take this one and divide it by that one, and you will get just square root of 3. Simple as that. Okay? Notice how in the third quadrant, all of these guys here, tangent was the only one that was positive. Okay? These ended up being a negative. Now, in the fourth quadrant here, okay, you guys can take a look at the values from the unit circle. Okay, so 300 degrees, x is 1/2, y is negative root 3 over 2. So I'm going to write down negative root 3 over 2 for this one. And cosine is going to be 1/2 because it's positive. And just like how I told you before, the fourth quadrant has a cosine value to be positive in this case, but then would make sine and tangent to be negative. Crisscross here, that will make it root 3 over 2 positive, but that will make it negative 1/2 negative. So therefore, if you were to, Therefore, if you were to take the sine over cosine, this will give me negative root 3. This will give me negative root 3 over 3. Okay, so those would be the values for the tangent. And make sure you have this in your notes because it's very important that you guys have these values with you when you're doing the problems that I'll present for you guys at the end. This is your important notes for today. I'm gonna ask you guys to find what we call a reference angle. Okay? Now the reference angle is always going to be something between 0 to 90 degrees. It's going to be something of a visual per se that you guys could use to find out SOHCAHTOA of very, very big angles. For example, 225 degrees. So if I were to ask you to find sine of 225 degrees, let's say you did not have a calculator with you, how would you solve that? If I were to ask you to find cosine of 135 degrees, you guys simply cannot draw a right triangle with 135 degrees. So you are not going to have those opposite, adjacent, hypotenuse things any longer. But what we're going to do is we're going to be using the reference angle to transform what we call these obtuse angles into an acute angle. And these are the four situations that you see right here. Okay? First, if it's in quadrant 1, whatever the reference angle is notated by theta prime, is going to be whatever that angle that's going to give you. So if this was, I don't know, say 60 degrees, then the reference angle is 60 degrees. As simple as that. Now in quadrant 2 here, you see that the angle will land you somewhere in this second quadrant. This is the entire angle. And like I said, you cannot use SOHCAHTOA for that because that's not a right triangle. The reference angle, okay, and I want you to think of this in your head as well, it always has the base at the x-axis if you guys take a look. Now what I mean by that as a base is that it starts from it. So if you take a look at the red arrow sign here, it starts from this axis and goes up. it starts from this axis and goes up. Starts from this axis, the x-axis, and goes down. Starts from the x-axis and it goes down. So the base, where it starts from, okay, where it starts, it has to be in the x-axis. So therefore, if you take a look at the reference angle for quadrant 2, imagine if this data was, I don't know, 120 degrees. The reference angle that you have to use is going to be 60 degrees. Why? Well, because if you guys were to take a look at how sine of 120 before, sine of 120, okay? I don't know why I can't write on it. Ooh, okay. I need to most likely be charging the pen real quick. Just give me 1 second. Okay. All right. So, back to the topic here. If you guys were to take a look at the sine and sine of 120 and sine of 30 degrees, I don't know if it's gonna work while it's charging, but let me give it a try. Let's see. Okay. I have like 2% right now. So first, just bear with me here. So imagine what will happen if you were to take that 120 degrees and the 60 degrees and take a look at the sine values for both of them. You guys should be able to find out that these two are going to give you the exact same thing, okay? And what do you know is that if you were to take also the 135 degrees, for example, and the reference angle to that would be 45, these would be the same. Now, I understand that the cosine value will not give you exactly the same thing, okay? Because one is negative, one is positive. But that sign is what you just need to take accounted for at the very, very end. But what I want you to focus on is the numerical values. This is 1/2, and that is 1/2. It's literally just a reflection across it, right? So if you were to fold it from here to here, like all of these values, here to here, here to here, here to here, they will all match up, okay? So that's why the reference angle is so important, because it just gives you it gives you correct numerical value for your trig functions. So if I were to ever ask you to find the reference angle of 120, you would be using this formula right here, where if it's in degrees, you would do 180 minus the theta. So 180 minus 20 gives me 60. Or if this is, let's say, I don't know, 120 is pi over, actually no, it's going to be 2 over 3 pi. So 2 pi over 3, that means that I'm going to subtract pi minus 2 pi over 3 gives me pi over 3. So, you know, just same thing. Remember that radians and degrees are interchangeable. Now in quadrant 3, it's a little bit different because your angle would be somewhere around 210 degrees, for example. And if you go back here to the table that I've shared with you guys, 210 degrees, let's take a look at the sine values. 210 degrees, negative 1/2, okay? It gave me negative 1/2. Now the reference angle to that would be 30, because following this formula, you would plug in 210 degrees here and you would subtract 180 from it and get 30 degrees. This is the angle that we're talking about. That is the acute angle that we're talking about. So if this entire thing was 210, I want to subtract away the 180, get rid of it, and get the rest of it, which is only 30 degrees, right? So the 30 degrees would end up being your reference angle, and that will allow you to solve for the value. Now, I know that 210 and 30 does not give you the exact value, like not the sign that's accounted for, but as again, the numerical value always matches up. That's the beauty of it. So, once you have the numerical value, just put the negative sign in front of it, because you guys already know that in third quadrant, only tangent is positive. We'll go over this also, but there's 4 acronyms: A for all, this is S for sine, this is T for tangent, and this is C for cosine. These letters represent where it's going to end up being positive. It's really important that you guys write these down. ASTC. So there's an acronym that we use that all students take calculus. If we were in class right now, it would have been lovely if you guys could come up with your own way of doing this ASTC acronyms, but that's just class interaction thing. But let's go back to here. So this one is 30 degrees, and that's your reference angle that you're going to be using to solve for any trig functions that you might have. Quadrant 4, remember that you're going to go all the way around like this, all the way around, and you end up somewhere in the 4th quadrant. That means the rest of the pie slice would be your reference angle. So therefore, it's whatever 360, okay? The entire thing minus the entire angle that's labeled for you guys. I'm going to color code it so it's easier to see. In purple. So if I get rid of all of this guy out, then I'm able to get this rest of the remaining portion. Which means if this, let's say this entire thing was 300 degrees, 360 minus 300 equals 60 degrees, and that remaining part is 60. That's your reference angle you would be using to solve for the trig functions from there. Okay? Let's tackle on some of these problems, okay? And then what I'm going to ask you to do is I'm going to ask you to do the guided practice on your own. Now, there's no way for me to check this other than if you want to write this on your notebook or, show it to me on top of the homework assignment that you're doing, that's fine. But just write down the question for me if you're going to do that. For sketch each triangle, then find its reference angle here. You're going to just draw these rectangular coordinates, and 210 degrees. It's always starting from the 3 o'clock position and going to go all the way around like this. Okay, how did you just do that, Mr. Ken? Well, this is 180 from here to here. It's a semicircle, and you just have to go additional a little bit more, maybe about 1/6 of the way. No, actually 1/3 of the way because it's 30 degrees. 30 degrees extra, right? So this is 180, and this is 30 degrees. That makes it 210. So the reference angle, which quadrant am I in? Well, I'm in quadrant 3. Quadrant 3 tells me that the formula is the reference angle is theta minus 180. So reference angle is theta minus 180. That's going to give me 210 minus 180 because it's going to give me 30 degrees. And then I'm done. That's 30 degrees right there. And visually speaking also, this is the x-axis. I told you that was the base. This is the angle that it's going to create with the base. Okay? So that's always your reference angle. Now, the second one, it's a little bit of a pain because you have to convert it into degrees first. Or if you're comfortable with radians, that's also fine. But I'm going to share with you guys how to deal with also negative angles as well. 5 pi over 4, if you guys are having trouble with understanding what that might be in terms of radians, that's negative 225 degrees. Remember, to go from radians into degrees, you just have to multiply by 180 over pi. Whatever the angle is, just multiply by 180 over pi. Pi's will cancel out, and you get the idea. Or just substitute pi as 180 into the equation, and you'll get the answer as well. Now, remember, we're always starting from the positive x position, and we're going to move in negative direction of negative 225 degrees. That's all the way around like this. Remember, that's 80 degrees, and that's additional 45 degrees like that. I guess I already told you the answer because this should be a reference angle, or other words, you're going to do the reference angle formula here. It's in quadrant 2. So quadrant 2 says reference angle is 180 degrees minus theta. Okay? So if you guys were to actually plug it in, you're going to get something actually totally different. But theta reference angle will be 180 minus the angle that's given to me as negative 225 degrees. And that would give me in total way more than what I actually hoped for, 405 degrees. And I hope you guys can kind of see that really just absolutely makes no sense. But this is a two-step process if you want to think of it this way. 405 degrees means that I completely loop around the circle. Okay, let me draw it for you guys here. I completely loop around the circle 360 degrees, and I go additional, couple degrees more, which is 45. Actually, I have to, the battery ran out on me again. But it's 360 and it's additional 45 degrees. So even though when you see 405 degrees, what I want you to realize is that We're going to be talking about this with you guys in the future as well. It's called coterminal angles. Coterminal angles, you're going to either subtract 360 or add 360 to get that reference angle always. So let me just check the batteries here. Hopefully this is good enough. Okay, so you're going to subtract 360 because, you know, one complete cycle, actually I have to erase this part because it doesn't go about this much. 45 degrees is going to end up reaching here, and that's going to be it. So why can't my reference angle be 45? Well, remember, 405. Well, 405 it's not between 0 and 90. Guys, remember, your answer for these two parts should always be between 0 and 90 degrees because we're talking about acute angles. Okay, so that's going to be 45 degrees. This question, I didn't want to talk to you guys about negative sign. I didn't want to talk to you guys about coterminal angles, so that is going to be a little tricky. But for these guys, I don't think it's going to be a problem. Remember, this negative sign means that you're always going in the clockwise direction rather than counterclockwise direction. Okay, so just try these two problems on your own and tell me your reference angle. Remember, the reference angle always has to be between 0 and 90. That's a must. Don't ever forget that. Next, well, sketchy triangle, then find its reference angle. You guys can do that as well. Because the video is getting a little bit longer than I expected, I'm going to actually stop you guys there. For tomorrow, I'm going to show you guys how to find the exact value of each trigonometric functions. For today, please work on these 5 problems. So 3A, 3B, and then 4, 5, and 6, and then also show it to me on the piece on the paper. Now, for your homework, please keep this in mind. The homework also has questions dealing with finding the exact value of a trigonometric functions that I plan to share with you, but the time is getting a little bit longer. So please work on only the one that's asking for the reference angle. I'm also going to write this on the Google Classroom, so just please keep that in mind. All right, thank you and have a nice day.